dream at the edge of the sky, and your life is a story like the wind. Your life is a story like the wind. I'm searching for the spirit of the great heart to hold and stand divine. I'm searching for the spirit of the great heart under African skies. I'm searching for the spirit of the great heart. I see the fire in your eyes. I'm searching for the spirit of the great heart that beats my name inside. Sometimes I feel that you really know me. Sometimes there's so much you can show me. I'm searching for the spirit of the great heart. Who comes in my side when you see you? I'm searching for the spirit of the great heart. Who comes in my side when you see you? I'm searching for the spirit of the great heart to hold and stand divine. I'm searching for the spirit of the great heart under African skies. I'm searching for the spirit of the great heart. Who comes in my side when you see you? I'm searching for the spirit of the great heart. Who comes in my side when you see you? I'm searching for the spirit of the great heart.
Good morning, everyone. I can see we've got some attendees coming through into the session. So I think let's kick things off. I hope everyone was pumped after that fantastic song. So welcome, everyone. My name is Claire Pengeli. I head up the Water and Agriculture program at GreenCape, and I'm going to be your chair for today. So to kick things off, if we can switch to the program that will be running through, please. Fantastic. So that's me kicking things off. And as you can see, we've got a really jam-packed agenda for today. So shortly after this, I'm going to hand over to my colleague Ashton to talk about some of the work that we've done around water resilience strategies. Then I'm going to ask our colleague from DDAT, Rabalani, to speak about the Western Cape support to agri-processing. Then we'll hand over to Lindani Ntwane from the National Cleaner Production Centre to talk about some work that they've recently published. Then we'll ask Jacques Rousseau from Distel to talk about some of the work that they've done there. And then we're going to go through some of the really key resources that support the agri-processing sector in terms of thinking about their water and waste management opportunities. So these are the NatServes. So we'll be going through with the authors of some of the recent NatServes. First, we'll start off with Chris Swartz, looking at the vegetable and veg industry. Then we'll hand over to Pamela Velt from Hill. I'm going to be the timekeeper. Those speakers that
Thanks, Claire. I think Claire is having troubles with the connectivity, so maybe let me kickstart my part. It's good morning once again. My name is Ashton, and I'm also a water analyst at GreenCape. So I'll be taking you through what we have termed the water resilience journey. This is the work that comes from what we
You'll
did.
hear some polite.
Okay, Claire is muted now. Okay, so I'll take you through what we have termed the water resilience
Some
journey.
polite coughing in the background. And then just to then okay, Ashton is going.
Okay, thanks, Claire. Apologies, we have been breaking up a bit. So I just jumped over to start off my session. But thanks once more for the introductions. As I've introduced myself, my name is Ashton. I'm also a sector analyst at GreenCape. So I'll take you through what we have termed the water resilience journey. This comes from the work that we did during the drought, where we engaged different businesses and encouraged them or supported them in terms of how to become water resilient during the drought. So I'll take you through the 4 steps that starting off from your far left, which is what you call understand water uses and risk. So the journey starts from your left to your right, which is all about from the left, it's a low cost activities or interventions. And as you go far to your right, the cost increases and the complexity as well. So from the start, for agri-processors, I think one of the most important things is to understand your water uses and risk. So one can appoint a team within the operations, also do water audits, and also understand your water quality requirements. So we have always spoken about, fit for purpose water use. So you need to understand, your water usages so that you can strategize or find ways of conserving water. So most importantly, we talk about the smart metering or metering and monitoring, where you will install a smart meter that will detect any leakages within your operations. And also it will tell you about your daily uses. So that's a smart way of doing things. Then the second step is now, after you've understood, your water uses and you understand where you're using most of the water, and we have even strategized, in terms of what can I do to reduce my water use. So you have your behavior change now, so now what to do. You call your team together, then you advise on ways to conserve water. And also there is a low-hanging fruit, which is all about, using efficient fittings and technologies, or using efficient processes. So one of the easiest things is to, rather than using hose pipes for cleaning floors and things like that, you provide alternatives. And even using high flow water, you reduce the flow by employing aerators. So if you look at first stage and second stage, we have discovered that from our case studies, an industry can actually save up to about 30% in terms of water consumption. And then the third step, which is a bit complex, is talking about water reuse on site. So you understand your water uses and your water quality requirements within the process. So this allows you now to look into ways of reusing water on site. So we're talking about grey water reuse, maybe most relevant to laundry and textile industries. We talk about, your processed water, industrial effluent that can be treated on site, pre-treated or thoroughly treated to an extent that it can be used within the operation rather than always tapping into potable water. Also black water, of course, that might apply to, the use of pollutions, but it might not really apply, to the different industries. But the technologies that treat black water, they are biological and can be used in the fruit and beverage sector or dairy sector, where you're dealing with organic wastewater. And then lastly, now we tap into what we term the alternative water supply. So an industry can decide, to install rainwater harvesting techniques or stormwater harvesting, or even using treated effluent. If you're within the city of Cape Town, you can actually buy treated effluent from the city, or you can also use groundwater. Of course, this might need an industry to first treat that water to a standard that is usable within the operations. So ladies and gentlemen, this is what you call the water resilience journey. So as I've said, moving from the left to your right, from the left is low-hanging fruits, easy to install, quick fix, and also cheaper. but as you go further to your right, you're increasing the complexity and the expense as well. I hope our special guest today that will be speaking will touch on these different interventions that can be employed by the different agri-processing sectors. I think my duty ends here. Thank you very much.
Thank you very much, Ashton, and very insightful overview of the opportunities in the water resilience space. I'd just like to carry on a little bit of the introduction. If you could introduce yourself in the chat, we'd love to hear from you, who you are and where you're from. And we welcome you to add any questions in the question and answer box for our speakers. We're going to be taking questions after each speaker, so please feel free to post them as we go along. I'd now like to introduce the first poll of today. We'd just like to find out who is in the room and how we can assist you better. So let us know what is your interest and your background. And then I'm going to, while you're answering this poll, just introduce our next speaker. So our first speaker is Mr. Rabelani Chilanka, who is the Director at the Department of Economic Development and Tourism in the Western Cape. He is leading the Green Economy Programs Unit, mainly focusing on economic water resilience. So very warm welcome to Mr. Rabelani Chilanka. He has 17 years of working experience within government, having previously worked for the Department of Minerals and Energy and the Energy Efficiency and Environment Directorate, the Department of Environmental Affairs as Climate Change Mitigation Director, and the City of Johannesburg as the Head of Climate Change and Resilience. So we're very honored to have him as our introductory guest speaker, and we'll hand over to him in just a moment once we have closed the poll. So let's have a look at who's in the room. So I see the poll results there. We have consultants, researchers, and solution technology providers. And we hope we'll have a bit more participation for our next poll. So I'd like to now hand over to Mr. Chilanka. Thank you very much for joining us and for starting the introduction.
Thanks a lot, and thanks a lot, Rudy, for this opportunity. We've been working together with GreenCape for quite some time. And as per the introduction, I would like to thank you for this opportunity. I am happy to really talk to you this morning as a new director for Green Economy Programs and Projects in the Western Cape, Department of Economic Development and Tourism. As Rudy has said, focusing on economic water resilience. Department of Economic Development and Tourism recognizes the importance of economic water resilience as a key priority of the department. Work has been done to improve economic water resilience of the agri-processing sector. In 2019, DDAT ran a piece of work which looked at where the key water risks were and where the challenges and impacts across the agri-processing sector and subsectors are. We zoomed into details on the fruit and vegetables and dairy subsectors. The department engaged with key industry players on what needed to be done to improve water resilience in the agri-processing space, including on how to work with key players to move forward the agri-processing implementation plan that we developed. But due to COVID and other priorities in the energy sector and also capacity issues, this work was only a light touch, and in most cases it was paused. More support was given via the water sector desk, working with GreenCape, as I said from the beginning. We have also been engaging with key industry players, the likes of NCPC and IFC, to coordinate on who is doing what in the green economy space, and also to provide any systemic support needed. We are now looking at picking up some of that work in the agri-processing sector. We would like to reach out to you to engage further on how best we can continue working on this sector, as this sector has been prioritized by the department. In the past months, we have been zooming into the Green Economy Strategic Coordination Workstream, amongst other things, focusing on the 110% Green Web platform. The platform enables us to provide a space where some of the new technology developments can be tested while building the green brand of the province. It is a dynamic platform established to catalyze and encourage practical actions from Western Cape-based organizations that links up to the green economy work. So you are really invited to, complete our database to showcase those technologies that we have, that we could then be able to use this platform for that particular purpose. Working through the water sector desk as an important sector, with priorities to engage key players on the agri-processing implementation plan, the department would therefore like to use this opportunity to check out where the priorities are, where the key needs are, and where the province and other players might need our support as we improve economic water resilience in the province. I thank you. Thanks a lot. Over to you, Rudy and colleagues. Thanks.
Thanks very much, Mr. Chikalanka. Mr. Chikalanka is from our funders at DDAT, and we really appreciate the funding towards this research and agri-processing. I'm now going to hand over to Mr. Lendani Mfwane. He's a professional chemical engineer, currently in the role of project manager at the National Cleaner Production Center of South Africa. He is involved in both the Industrial Energy Efficiency Project and Industrial Water Efficiency Project. And he has over 15 years of experience in process and project engineering in various industries, including heavy industries, the chemical sector, autocatalytic convectors, and the agri-processing sector. The NCPC have recently published guiding documents in water efficiency best practice, and we really welcome this introduction to the recently published documents. The NCPC will also be hosting a full webinar introducing these documents on Thursday at this time. So I invite you to join their full explanation after this as well. Thank you very much, Landani, over to you.
Thanks very much. Thanks very much, Judy. I will just want to just take you through the Industrial Water Efficient Project. I'm assuming that my camera is not on. I'm not sure whether you can see my face that side. I will just quickly show my face, and then I will just quickly close the camera because it's affecting the presentation. I will just stop it, and then I will open it whenever it's required. Okay, thanks, Rudy, for that introduction. So as you've introduced myself, I'm Lindani, the project manager for NCPC. I'm currently based in Durban. We've got head office in Pretoria. We've got other regional offices in Cape Town as well as in Durban. Okay, just the overview that I will take you through about NCPC, South African water challenges, as well as NCPC response to that. A look at the work we've done in the past. We'll just take you through a quick case study, as well as the current work that we are currently doing, as well as future work, which is exciting within the space of water efficiency. Just to give you a background of who is NCPC, we are a National Cleaner Production Center of South Africa. We support South African industry to improve competitiveness and reduce environmental footprint. We do that through implementation of RCP methodologies, where program of Department of Trade and Industry and Competition. We are hosted within CSIR, which is the Council for Scientific as well as Industrial Research. So the services that we offer to industry are highly subsidized, and the aim of that is to stimulate, support the uptake of the RCP by industry. We do that through assessment, implementation, where we get case studies. We also do that through skill development, where we've developed training courses on various thematic areas. Also, we've got RCP tools which are online, as well as sector guide that we've developed, which are also online. Also, we do that through awareness, as well as policy advice, as well as various workshops. In terms of the flagship project that NCPC is driving, we've got 3 areas: water, which is industrial water efficient project. The second one is the material and waste. We've got a program there, it's called Industrial Symbiosis Program. And under energy, we've got an industrial energy efficient project. I just want to take you through the water challenges, as well as what NCPC has done in terms of response. As you know, South Africa is a water scarcity country with extended drought, as well as aging water infrastructure. We've got really a big problem in that. Also, there is inconsistent policy and regulation. Preferential effluent charges for high volumes that we typically will see. Also, unreliable water supply and quality, which is coming from the water system in South Africa. Also, there is very much limited investment in water efficient and measures and programs. And also, there is limited knowledge and skills in water conservation, as well as effluent management. As you can see, what is highlighted on this graph, what you call the intervention, the cost of intervention. The second one, which is the cheapest one, obviously, is it's water use efficient. Just like I think Ashton has shown on his presentation. The first fuel, obviously, it's water loss control, where you will obviously, if you can fix water leaks, you can easily make sure that you beef up your water supply and obviously reduce your cost. As you can see, the water efficient is the second biggest response opportunity after the loss control. So that is basically the first thing, which is basically like a low-hanging fruit that the industries can use. Also, in terms of the water challenges, as well as what NCPC has done. NCPC has embarked on creating a project within NCPC. We launched the project early in 2017 with different types of partners. The program has got 5 areas. The first one is to facilitate and enable policy environment. We've done that one. The second one, obviously, is establishing and promoting the adoption by industry, the national and international standard for water management. The third one is development of the relevant skills to support the implementation for water efficient through training. The fourth one is to now support industry plans to implement water efficient and obviously demonstrate the benefit by doing that. The last one is to deliver focused advocacy as well as awareness campaign to obviously again promote the adoption of water efficient by industry. So this basically has been our response to this end. And we've got delivery partners that we work with, the Water and Sanitation Department, the CSIR, the Council for Scientific and Industrial Research, the Water Research Commission, as well as the Ministry of Foreign Affairs of Denmark, the Danish. We're working with them. We've signed an MOU back in 2017, like I've already mentioned. Also, we've got other international partners, which is the IFC, International Finance Corporation. So I will just quickly just take you through a very good success story in South Africa. When we've done back in 2016, we engaged with a company. They were having quite high water usage. We engaged with them, and obviously we started to understand exactly where we can offer support. The site details is obviously it's a chicken processing facilities. It's located in the Northwest province. They were having problem with increasing water cost yearly between 18 to 20%, which meant really that they were in a tight corner. Also, the facility consumption contributed approximately 2% of the municipal supply in a water stress region already. Like I've already mentioned that in South Africa, the 7 out of the 9 provinces has already been declared drought-stricken areas. So this one was one of them as well. So the site approach that NCPC has taken, obviously, is to engage with the company, understand exactly what is their problems. We've done obviously just a mapping, an end-to-end process of the mapping of the facility. We've contracted a consultant to assist us with that. We've done a water balance. We've plotted exactly the consumption patterns as well as trends that we're seeing, and we've done the full scoping for them. And we've identified high water use areas. We've identified those areas as well as options to explore to reduce the consumption as well as to save on savings. What was interesting enough, the business followed through. We've done a detailed assessment after we've done a scoping for them. We've done a detailed assessment, and then we've presented to them the result to say these are the identified areas where you can save. Typically, our recommendation, they will start from a low cost and no cost option, medium investment cost, sometimes to a high investment cost option. For this one specifically, they follow through. The next following year, they've implemented 3 of our recommendation, and really they did not spend much on capex. They only spend a few thousand within their maintenance budget. The first one, which is obviously an intervention that they've done, was to obviously installation of a shut-off valve at one of their section, and upgraded their water system as well. And after they've done that, they've really raised the awareness raising within the facility to make sure that the water now is not left open, and all the leaks are being fixed. They fixed the leaks, especially on the hot water system, and by doing that, that also assisted them to reduce their cold, and the results were really immediate. The results were immediate. The last one that they've done was to, in fact, by doing those 2, what it meant that since they've managed to reduce their water consumption by over about 17% on the water consumption, that has meant as well they've managed to reduce their what you call their effluent volumes as well, because they've managed to reduce their water consumption for the site. Also, their water water use intensity improved by 11% within a year, which was really a very good implementation by the company, where they followed through on our identified what you call recommendation, and then they reap the result. And now really they've reduced their water consumption they are saving on cost as well, which is very encouraging, which shows that our work as well as intervention really works. So I'll just take you through also the current and future work that we are working on. We are having, like Rudy has mentioned, on the 17th, which is this coming Thursday, we are having an industrial online workshop on the 17th of February. And you can register on our website. It's quick. It can take you 3 minutes to just register yourself for that workshop. The tour will be now sharing with the wider industry all our tools, all our sector guide that we've developed. We've already published them on our website. The first one is a water audit protocol that we've already published. The second one is Agri-Processing food processing guideline. It's having 5 common what you call recommendation, which can be easily be implemented in any sector or business. So we'll be obviously sharing that one thoroughly or in detail in that particular workshop. Also, what we've developed is a qualitative water loss logging tool that we've developed as well. We'll be sharing that on this day with all the people in industry. The third one that we are currently working on now is water training modules. We will develop a 2-day end user water training modules that will cater for basically for anyone in industry, from someone running the machine to even a business owner, CEO of the company. The fourth tool that will be releasing soon as well to industry is what we call monitoring and metering guideline. It's also specific to agro-processing sector. We are working with the Danish partnership as well as the IFC on that one. And then after that, we'll be piloting it within the dairy sector in a course of by end of this year. So basically, these are some of the work that are exciting, which we are working on. Also, which we're hoping that there will be uptake from industry to obviously just take this and utilize them so that they can really reap the benefits. I thank you. Thanks very much.
Thank you very much, Nandani. That was a fantastic presentation, and we look forward to hearing more about your publications on Thursday. I have one question from my side, and then I'll take the questions from the audience. I'm just curious to know, a lot of your case studies that you presented, there was definitely a financial saving in each of them. Do you find that that is a critical factor in making these water resilience projects successful? Could it be another initiative that is making it successful?
Yes, definitely, Rudy. One of the things when we come into to the facility, we assist them by giving them or plotting for the facility. We plot them what we call it's a regression model, where we will plot obviously for them a model where they will use that model to predict their water consumption on monthly basis. That is basically the first and most critical step that we do, where we'll just use a previous 12 months, and then we'll create a baseline for them. And then once we've created a baseline for them, they will obviously will tell them that typically for your site, your base load maybe something like 20, or I'm making an example, 20,000 kiloliters per month of water that typically you use your facility. And then when we come back, when we've already given the company the option to obvious to say, these are your recommendations, start with your typically your low and no cost option. And then when we come back, we capture the case study. We will typically use the baseline to quantify the saving. We'll even go an extra mile where in other situations as well, we'll make sure that we put some sub-metering to obviously quantify what they are measuring. And then it's easy now to obviously quantify and put the exact number once we've already developed a baseline model for the company on how to predict their water consumption for the site. So that's how we do it. And then obviously we'll calculate for them, and then we'll show them how much they translate to their water savings. Yes.
Fantastic. Thanks very much. I'm going to take a question from the audience. We have a question here from Benoit Leroy, asking about the drought that you mentioned in 7 of the 9 provinces. He says, is it really the drought, or is it rather that our water reserve has been fully allocated in most catchments? Sorry. Over to you, Lindani. Thanks.
Okay, with that one, it's a combination of factors, but I think the drought has really worsened the situation. Because if we were to look at, for the longest of time in South Africa specifically, the way industry has been managing water, they've taken water slightly because they thought, okay, this is like an abundant resource, and they did not necessarily put much focus on water. Up until drought hit, and now they saw that we're going to like the water supply reserve, we're going to like 0 levels, and then now the forecast changed. So what I'm saying is that there is a combination of things. Like I've already mentioned that also there is a big problem of aging water infrastructure from the municipalities, of which it's really a big struggle in South Africa. And it will really take not only industry, but it will take different stakeholders to really try and manage the situation. But I think big industries or big companies, what they've done, they've taken water as a business risk going forward. In fact, from 2017, they've already taken water as a business risk. By that, they've made sure that they come up with different types of strategies in terms of their water supply. Could be drilling boreholes, could be things like water harvesting is one of a low and no cost option. A lot of companies are just doing that because it's a no-brainer. You have to obviously just make sure you've got enough water supply. What I'm saying in a nutshell is that the combination of issues, but drought has really elevated the current issues of which are well known. That's what I can say. Thank you.
Thanks very much, Lindani. I'm going to continue now to our next speaker. I know we do have some other questions, and if we don't get to your question, please do keep them coming. We will ask our speakers after the session to answer your questions and revert back to you. So now, thank you very much, Lindani, again for your presentation. We're going to do a trial and see if our next poll will work. So if you could please respond to our next poll about your interests in this water sector. It should be popping up on your screen now. And if you could fill that in for us, that would be great. So our next speaker I'd like to welcome is Mr. Jacques Rousseau. He is the Group Environmental Sustainability Manager for Distel, which involves supporting and advising all distilled production sites located in South Africa, Scotland, and the rest of Africa regarding environmental legal requirements and compliance, and ensuring projects are implemented to reach their environmental improvement targets by 2025. and beyond. We're really honored to have Jock with us. He has an honors and masters in microbiology from the University of Stellenbosch, with over 10 years of experience in environmental protection from the Department of Water Affairs and Forestry. So thank you very much, Jock, for joining us. We're just going to close the poll quickly. Thank you very much all for your contribution to the poll. I see we have some interest in new technology descriptions. So I hope that the best practices and the case studies that we're sharing in this session will give you an insight into that. There's also a lot of interest into case studies, and you can look at our GreenCape website for some case studies that we publish each year. So thank you for this insight, and we will endeavor to support those interests. Over to you, Jock. Thank you very much.
Yes, morning, everyone. Just confirm if you can see my screen or the slides.
Yes.
Yes. Okay, thank you. Yeah, thank you. Thank you for the invitation and allowing me to present. I think, and from my perspective, I'll go through the work we've done sort of the last few years, and then just stand still a bit on the Western Cape Trout work, but maybe just is this nice? Sorry, let me just, it's now stopped. There we go. So just for some background, just in terms of the company itself. So you've already mentioned that we obviously have multiple production facilities in South Africa and then also in Scotland and in Africa. So the focus of the presentation will be specifically around the South African work, and then on the Western Cape side as well. So I think just as a start off and a snapshot of where we started. So we initially, I mean, the work that I'm presenting is work that started in 2010 already. And we started off getting an understanding of what that sort of baseline situation is. And at the time, just from a water use efficiency perspective, we were using about 4.2 liters of water per liter of packaged product. So basically going from the point of final packaged products. I'm understanding our processing. We do make obviously wine in a certain time of the year, and that product is then kept until it's packaged. So we worked on whatever is the final packaged volume versus what you might have been produced throughout the year. So there is some seasonality impact as well. And some of the initial work we did sort of brought it down to 3.9, and then we're standing target for the end of this financial is just below 3 liters per liter of finished product. And we obviously aligned this very closely to the Sustainable Development Goals around water use efficiency and water use, etc. Now, there we go. So where we started off in 2010, and again, I'm going to take you through this journey process that we've gone through is we started off by putting in a proper monitoring and reporting system. So making sure that we have duplicate monitoring system on our side and not be fully dependent or only dependent on municipal measuring systems. We put in centralized reporting systems so that all sites report centrally to our corporate center in terms of what the water usage is. We did full water network analysis around understanding sort of water flows through the process. We put in sub-metering for areas that were identified as potential high water use areas, and started sort of at site level and not just comparing, let's call it a municipal meter to our own meter, but also comparing sub-metering to our own meter to understand where potentially there could be leaks or whatever the case may be. So the first set of work was getting that baseline, and then from that we started looking at projects. These were typically projects identified internally of where we could obviously reduce water usage, and there's a number of those. So the Springs plant, recycled pasteurized water use, which is just reducing the temperature of the water and allowing it to be reused. There was recycling, for example. We've got reverse osmosis plants where we treat municipal water before we use that in the final product. Now the brine stream from that is fairly clean, so we would use that then for washing our floors. You know, if we buy in new bottles, we would rinse that bottle before we fill it with finished product. That bottle rinse water again is fairly clean. We use that again, washing our floors, taking it into cooling towers, etc. And then we did work with, and I think Lindani from NCPC also sort of referred to that, but we used independent engineering consultants, and we then did water audits at all our major sites, effectively using the data which we've now built up, going through each process, and almost getting a new view of where potential opportunities existed, to look at further opportunities to reduce water usage and to in-process recycling. So we did some work with WWF, looking at the water risk of our different sites and understanding more on a broader scale what is the risk of interruptions to water supply, both in terms of, let's call it drought, in terms of precipitation and water availability, but also understanding where potential risks are in terms of municipal infrastructure and interruption of supply from that perspective. And then we obviously continued when, you know, we were sort of in that sort of day zero drought scenario in the Western Cape. There was a lot of work then done around further improvements, firstly in terms of reducing water use at those sites. So at our largest site at Epping, we sort of had to temporarily relocate production. We put in closed loop cooling systems at one of the distilleries. We did major work around obviously awareness programs, as you can imagine. And then we completed additional water audits at 2 of the sites. So we've basically done water audits at all our major production sites. We've developed let's call it a list of opportunities or projects at each of those sites. And then on an annual basis, we align that with our capital budget application process and then implement those projects progressively at the different sites. That implementation program is also aligned to our annual water improvement target process. So projects that's identified for implementation will obviously then on a corporate side and on the site side lead to reductions for those specific sites. And there was a question now about drought. Obviously, the Eastern Cape is currently facing severe drought. So there's a lot of work that we're doing there in terms of replacing old infrastructure. So old bottle washers has been replaced, and we've just completed a project now where we're actually using the final rinse cycle from the bottle washers, which we're putting through our RO plant and reusing that back into that bottle washers again. So sort of that in-process recycling opportunities. So that work is continuing at all the sites. But I think if we look at the Western Cape drought situation, so I think the one advantage we had was the fact that because we had started working on water use efficiency in 2010 already, we already had a fairly well-established baseline. We already had done water audits at the key sites. So when we came to the situation where all of a sudden, you know, it became a regulation to reduce our water usage by 45%, against the 2015 as the base year, we already had a very good understanding of where those opportunities were. So we could fairly quickly, inverted commas, implement potential process changes. Obviously, engineering interventions would require you know, time for implementation. But because we already identified the project, there was already an indication of a cost element to it, we could then pull projects forward and fairly quickly get approval for the capital to implement those. So, you know, if we sort of looked at all the different opportunities, again, firstly looking at internal reductions, although a lot of work has been done already, we started looking at alternative water sources that included, you know, drilling of bore, safe yield analysis, application of water use licenses, water treatment processes, in addition to obviously make sure that the water complies to our sort of drinking water standards and internal product standards. And we also started looking at water reclamation from wastewater. So we have currently 4 facilities, or 4 of our plants have treatment processes which sort of follow fairly similar processes. So it is our internal industrial wastewater that goes to anaerobic, aerobic, ultrafiltration, reverse osmosis, sterilization, and then it's blended obviously with the municipal water as well, and we use that for utilities and washing. So non-product contact, we've got an internal policy that we don't use that for blending of final product. And then, yeah, so I said that the 4 sites that we already have that in place. Some of them are in different phases of commissioning and usage. So yeah, other than just that internal reuse opportunities, obviously have the opportunity to reclaim that water as well. So the process is continuing, and our longer term ambition is to reduce our water usage to below 2 liters per liter of production. So effectively halving our water usage as an efficiency measure from where we started off in 2010. If we and we are well on our way to get there. So still work to be done, obviously, but we are continuing with this work, so we haven't stopped with this. I think some of the learnings that we can sort of indicate is obviously the earlier you start with understanding your base and where opportunities are, the quicker you can react in terms of when you're in that drought situation. I think the other thing that we have found is obviously boreholes as an alternative water is still a natural resource. It's not an alternative. We might just be able to get that water on our own site, but it's still a natural resource. So whether or not we get municipal water from rain, or whether or not we get groundwater, we see that as a similar type of source, and it doesn't impact on our efficiency ratio. It's just an alternative source. I think the one thing that we've learned from the groundwater perspective, and if you look at the graph, you'll see the distinct difference at sort of in January 2010, or sorry, 2021. So we've done a number of sites where we drilled boreholes specifically as part of the drought. We also had sites that had boreholes in place historically for a number of years before that, and it's been operating on groundwater as a single source of supply for a number of years. And following the assessments we did on the new boreholes, all the yield assessments, some of them, well, they've all been issued with licenses since. We've gone through that process of obviously completing full installation, level loggers, water meters. We've started doing external quarterly monitoring reports for each of those boreholes. And based on those the safe yield assessments and those quarterly monitoring reports, we've amended our management processes. So you'll see, for example, in this first period, we had the risk then of potential over abstraction and having an impact on the resource. Subsequent to that, we have put in, for example, timers on our pumps to make sure that we abstract only to a limited period. And you'll see that we have a much lower risk of potentially running the water levels lower than our pump inlets. So the effective result is a much more sustainable abstraction rate, which assures us that our groundwater supply is more sustainable over the long term. So we implemented these interventions not just at sites which had a requirement in terms of licensing. We've now standardized this also for sites that were, let's call it in old terms, existing lawful use. So this is a standard practice now across all our sites where we have borehole. So we don't see boreholes as being a unlimited supply. We try and manage it also within the confines of what the resource can deliver for us. So just maybe as two summary slides, sort of to finish off with, is firstly, on a, let's call it on a strategic level, the process that we went through is combining an evaluation of each of the sites in terms of what the demand was, what is the let's call it the existing supply or the source of supply. We looked at potential alternatives, and this is almost now the more finished product, but we looked at opportunities to transfer water between sites. And remember, I'm not talking about period when we were sort of in the drought situation. We looked at opportunities for transferring water between sites. We had to apply for water use licenses to give effect to that opportunities. We looked at obviously reclamation of wastewater, new boreholes. So for each of the sites we developed at site level an understanding of what that situation is. We've combined this also with the results from the water risk filter work that we had done. And then we started implementing the changes to make sure that each of the sites, in terms of a risk perspective, has got a more sustainable water supply program. So this sort of gives us that one slide summary of where we stand across at least the Western Cape sites and the Eastern Cape sites. Obviously, a lot of work has happened since this, so this is not the existing or the final one, but just to give you an idea. So each of the sites, obviously, we went into a fairly detailed analysis of that situation, and we keep on doing this as part of our business continuity program. And then maybe just from a Western Cape perspective, as I mentioned before, there was a specific legislative requirement to reduce our water usage by 45% against our 2015 base year. So at the time we did a full analysis, understanding each of the sites, the source of the site, what was the demand, and we compared to what the sites had received water from the Western Cape Municipal Supply System, or at least linked to it. And we also looked at what, across the Western Cape as a totality. And as you can see, we were able to get to the 45% against water supplied from the Western Cape water supply system versus a total of 40% across the whole of the Western Cape. So again, a lot of work has been, a lot of successful work has gone into this process. But I think the key thing for me is the fact that we had started early. If we had started this process by the time that the drought was already in place, we would definitely not have been as successful as we were. So I think that's maybe the one key thing to take out of it is don't wait too long until you're almost in trouble already, but to start early with this. There is a long-term planning process that takes place. And the benefits both from a water use perspective and from obviously there is a cost-saving perspective as well. It does add value in the long term. So I think, I think that's my time. So thank you very much. I assume if there's any questions, please feel free to ask.
Thank you very much, Jack. Very insightful presentation, and I'd like to reiterate the comments in the chat. It's a very impressive water resilience strategy and implementation from Distel. So I think we can all say congratulations. It's a very impressive achievement. And as you mentioned, starting early is very, very important. I'd also like to just reiterate the groundwater sustainable use approach. I think it's a great strategy to think about it as the same as rainwater. And so if anybody has questions on the sustainable use of groundwater, GreenCape has published an industry brief on that, and my colleague will share the resource in the chat box with you, but please feel free to get in contact with us for more information on just what Jock has mentioned there as well. And now over to the questions. I'd also like to ask this question. So this is from Benoit Leroy in the chat box. He's asking, how does Distal compare internationally with its peers? And I'd also like to know internally, Distal South Africa with its international compatriots in Distal, how does the liter per liter KPI compare within your industry and within your business globally?
Yeah. So from a let's call it alcoholic beverage industry perspective, the best benchmark we have available at this stage is a industry entity called the Beverage Industry Environmental Roundtable, which represents a large percentage of the alcohol industry internationally. I think it's about 1,600 production sites. It is available on the internet if you want to look for the report. That industry average is 2.5 liters per liter of production. It, however, does include water bottling. So as you can imagine, your water usage related to bottling of clean water will be a lot less. There's a lot less processes involved, so that does slightly skew that number to the lower side. But be that as it may, so industry average from that perspective in the alcohol industry is about 2.5. We're currently slightly over that, as I indicated. We are towards the end of this financial year, target is 2.9. But our end goal is to be below that average at below 2 liters per liter. So moving towards that industry based, let's call it best practice. The difference between our South African activities versus our, let's call it the Scottish or the international ones. In South Africa, it's a lot lower. In comparison, overseas it's about just over 3. And the reasoning is, and again, there is obviously difference in as you can imagine, in the Scottish side where water is more abundantly available, and hence there's a lower risk in terms of the drought perspective to that. However, from a company perspective, it's still one of our key KPIs. In fact, it is also one of our company sort of short-term incentive one. So that performance is also part of or contributes from a sustainability perspective to potential bonuses. So our bonus is not only dependent on financial performance, but also around bigger, let's call it sustainability elements, of which water is one. So there is a difference between our South African operations to international South African operations. Again, big focus on that. On the international ones, there's a bit more focus on, for example, greenhouse gas emissions, etc., which is focus in South Africa as well, but there's that sort of difference between the two. So I hope that makes sense.
Yes, thank you. It's very interesting that you're targeting it globally to reduce your water use. The next question is about brine reuse. And as we know, there's some recent regulations that have come into South Africa in 2019 about preventing brine from being disposed at landfill. And so the question is, what does Distal do with the reverse osmosis brine?
So that's always an interesting question, and I think that's probably one of the, if you can get an answer to that one as a complete solution, I think that would be for the water industry a very significant outcome. So at our sites where we do reclamation of wastewater, those are all sites that currently already discharge, let's call it a salt load. But that salt load is now obviously diluted into a larger volume. Where we then do water reclamation, we don't obviously do 100% water reclamation, as obvious. The brine component still goes to municipal sewer. So the salt load, let's call it kilogram or a ton of salt stays exactly the same, but it's in a reduced volume, so it's obviously more concentrated. So we do have discussions with the local authorities around that. So we're not, let's call it, adding an additional load of salt to the municipality. It is just more concentrated, and we manage that with, obviously, in discussions with the local authorities, and to date we have approval for that. So at sites, so the 4 sites where we have those are all connected to the municipal sewer system. It's not connected to off-site sites where we potentially would have to then, take the brine to alternative sites. But yeah, that is discussed with the local authorities as relevant. And to date, the understanding has been from the local authorities that because we're not adding additional salt to the system, but we are concentrating, we have approval for those processes. It's always obviously an agreement with municipalities around that, but it is a difficult one. You are concentrating so then you also need to understand what the impact then is on the system downstream of the municipal sewer system. So I hope that makes sense.
Yes, thank you very much. And one last quick question. What is Distel's approach to groundwater recharge?
Okay, so we don't do active groundwater recharge, but obviously as I've shown on that graphs, because we do quarterly groundwater monitoring, we have an understanding of what the response is from the groundwater system in terms of our rates of abstraction. So because we've done safe yield assessments based on let's call it current best practice, we have an understanding of what those rates of extractions are. So where we have found that we were not compliant previously, we've now made those changes to make sure that we don't over abstract, but we don't do active groundwater recharge, if that's the basis of the question.
Thanks very much, Jacques. It's been a fantastic presentation and very interesting responses to the questions as well. So thank you very much for joining us today. I'm now going to hand over to our next speaker. We now have Mr. Chris Swartz joining us for a presentation of NatServe 19, as you can see on your screen. Mr. Swartz is a professional consulting engineer at Chris Swartz Water Utilization Engineers. He obtained his bachelor's, honors, and master's degrees in water utilization engineering at the University of Pretoria. His expertise includes research and capacity building in water treatment, wastewater treatment, industrial effluent management and treatment, and water reclamation and reuse. So we're very pleased to welcome you with your wealth of knowledge today. Over to you, Mr. Swartz.
Thank you very much, Rudy, the introduction, and just briefly show my face to show I'm not a robot, as it always says on the questionnaires. And good morning to everybody and thank you, Ashton, for inviting me. Okay, so I'm going to give a brief overview of a NatServe that we did for wastewater management in the fruit and vegetable processing industry, which was really completed. We did this over the last few years. What I'm going to look at basically is just to give you a bit of a background on this project that we did. And then we'll focus on the 2 main topics after that normally, which is your water use and your wastewater management. I'm going to present some key findings then, and then conclude with a few recommendations. So the aims of the NatServe, and that is very similar to most of the NatServes, is to provide an overview of the industry, in this case, the fruit and vegetable processing industry. Second, to look and evaluate and document some generic industrial processes, then zoning in more specifically on this industry, on current practice, best practices, and then also cleaner production, And there we had with NCPC as well. In that regard, we going as per NatServe documents. We look at the specific water use or specific input for the industries in terms of a unit of final produce. So how much water per kilogram of peaches or apricot or liters of juice and so forth. We then had a look at wastewater generation. What does the wastewater of this industry look like? And loading, do that represent, and what is the effect on the environment? And basically to summarize all of this in terms of findings, guidelines, and best practices. So 3 products that came out of this NatServe. Firstly, obviously, WRC NatServe document. And then we had master's theses as well by our students as part of building in this industry that was at the Stellenbosch University, the students being Pierre Volskenk and then Christian van Schalkwijk. On the water side, more focused on the water use side, whereas Christian looked at the wastewater side, characterizing the wastewater and looking at treatment processes. So just further on, just to put this in context, so we see in the industry, basically fruit and vegetable comprises about 8%. To the right-hand side, what we have in the fruit and vegetables, we have canned fruits, canned vegetables, frozen fruits, we have dried fruits, and juices then obviously as well. The left-hand side here, some of the percentages, you can see apples make up about 1%. So apples, quite a big industry, and we have that in the Western Cape here to a large extent. Apricots, plums, and so on, a bit less. And then some of the other types of fruits, you get typically your avos, bananas, pineapples, quite big industry in East London. There's also some activity in land, or it's a Tweenie, but we're not covering that in the NatServes. And then some other gold fruits, mangoes, papayas, etc. So this map just shows where the concentrations are of these different types of fruit and vegetable processing industries. You'll see a concentration down here in the Western Cape, and then up in Limpopo province, Tsaneri and so on, we have a number of industries. And in Gauteng, there's a few industries, more the canning industries really, and some of the juicing industries. Now, we had an introduction or a speaker on of environmental planning and tourism. So they did a report on this industry, or in which industry, together with the dairy industry, were quite well covered. And we had things with them, and we included some of the information as well in our NatServe. It was a valuable study that they did by the OABS company based in Paarl. So we obviously, there's a number of the fruit and vegetable processing industries in the country, 14 total. We try to do that to be representative of all the various types and sizes, geographical locations of these industries. For the 5 of those 14, we had field notes, but then our first student here, Volskenk, he developed, or he used a model that he customized for his, where he recorded verbatim interviews and then basically analyzed that and got very good information that he used in his thesis. Geographically, 5 were in the Western Cape, 4 in the Eastern Cape, 1 in Gauteng, 1 in Mpumalanga, 3 were in Limpopo. Okay, this is just some pictures of what we took, which is this showing a very good practice to use normal hosepipe to clean up. Some on the water treatment side, ponds that they use, and some ponds looking better than other ponds, depending on where the industry is located. Okay, in terms of the specific water intake that they use, so we had a look at the different sections. On the left-hand column, you'll see they gives the listing. We never in that sort of studies name the facilities, so we give it an ID code, and then it's the types you see there: frozen potato products, canned vegetable, frozen vegetables, and so on. We had a look at the freshwater consumption per annum, or we could convert 2 per day as here, or vice versa. And then we looked at the production figures for the industry, and we calculated the SWI. On the right hand, we had a look at what was in the literature as well, mostly, well, obviously the international literature. We also looked a bit at what was in the previous NATSA study that was in 1991, the first one that was done. Just want to grab a drink of water, yeah. Okay, and then in terms of the wastewater, you can see that it can be quite a high organic load as measured by the chemical oxygen demand. You can see citrus concentrate second from the bottom up to 21,000 vehicle. So you would expect some treatment to be necessary, and often it would be a weak digestion to just get rid of the main COD load before do any further treatment. So screening is used quite a lot to get rid of the peels and things like that. And then pH can fluctuate quite a lot, but more towards the acidic state. So there would be some pH correction required as well. This fits on with what was presented earlier by NCPC in terms of your hierarchy, looking at options that you have from the least desirable to the most desirable, but that's just basically for background. So some of the key findings on the industry as such is there's a strong export-orientated approach. More than 50% of this fruit and vegetables are being exported. There's a lot of growth in the Africa market with the exports from the country. The industry is highly competitive and concentrated in nature. So, we had to sign NDAs for most of the industries that we visited. There are a few key players accounting for large portions. I mentioned, for instance, the pineapple industry in East London being the only big one in the country. So there is a number of large players. The locations generally determined by the proximity, obviously, of the raw inputs, but also water availability. You would find it where, obviously, there's water available. Western Cape is the leading host for the processing facilities, and most of the juicing and canning takes place down in the Western Cape. I mentioned the other provinces that are involved. In terms of the future, most of these facilities have long-term strategies for improving their water use, for reducing their water. And obviously, that has a lot to do with the price of the water. So the economy is very important there, but also the environmental consciousness, if I need that, or conscience. And then raw material facility as the main consumers of water. And I'll show just now some areas where it can be reduced, that environmental Department of Environmental and Tourism did a lot of good proposals in terms of resilience during periods, because these studies just came out of the 2016-2017 drought, so really relevant to dry and water scarce conditions. In terms of wastewater management, not a lot of advanced treatment is used. They tend to try and keep it simple as possible, especially where it's possible to use pond systems and then you can irrigate the water, but that's not always done according to best practices. So we have a number of recommendations in that regard as well. 3 of the 9 facilities practice advanced or tertiary treatment. That would be like membranes and very fine filtration, ultra and microfiltration. As I mentioned, rural settings most commonly use irrigation at the first disposal route. So some watering recommendations in the industries. Pressure reduction at hand washing stations. It can be a lot of water can be wasted. Elbow knee operated water distribution points, frequency of washing, ring main, central shut-off valves. But in general, I would say just looking at how you can better wash, because I mentioned that is one of the bigger uses of the water is to wash down the floors and the equipment. So if you can more effectively and don't use water that's not really required in the cleaning process, that is ideal. So things also like automated stop-start controls, devices using water nozzles and regulating your pressure. And yeah, those 2 bottoms seems to be a repeat of the ones. Then in terms of the DDAT report, PS1, there were some interventions proposed, public perceptions on the use of wastewater in the food industry. There is often, because this industry is very hygienic practices, reuse water is frowned upon. But we know that the quality of reused water can be made as good as you want. It just costs more, but you can provide a very good quality industrial water for use. But that is something, the perception to be overcome. Water augmentation options should include desalination of seawater. So if that's close enough to the sea, you can do that. Bear in mind, this comes with some cost for the reverse osmosis as well. Improved maintenance, and we saw during investigations and site visits that these trees that had very good strategic and maintenance plans also invariably had better SWI values as well in terms of their water use. Water savings incentives, financial support from local authorities are required. There's much lacking at the moment. And I think a lot can be done in that. And I think a bit later in some of my final slides, I suggest that as receiving further attention and research. Agri-processing companies sponsor water efficient appliances technologies. And here I can just mention the very good study that GreenCape did about 2-3 years ago, headed up by Jen, looking at all the industries in this sector, where are the areas of improving both on water use and water loading reduction. And I mentioned earlier about EC that's doing very good work, as was presented earlier this morning. So the way forward, a number of aspects affecting the fruit vegetable processing industry in the country need to be addressed. And some of these things that we now, obviously, since that last OABS project, the pandemic has crossed our ways, and obviously that this has a lot of effect on the industry as well. So that should be looked at. should look at low global pricing pressures, especially on the export market, what is required in terms of water use indices and wastewater loadings. What do you do during droughts? And there that Department of Economic Development report is very good in addressing all of those in appendices, report in tabular form. Impact of poor economic periods on the industry was basically went hand in hand to an extent with the droughts and the export regulations, and then changing consumer trends. That's an important one as well. And we had in our WRC project, this NATSERV, we had very good inputs from industry as well. So I think I'm getting to the end of my alarm. I've got 2 more slides, I think. Regarding water and wastewater management, some of these challenges are water availability, especially if there's droughts. What are the priorities given and allocations of water in these periods? Water quality is important, the intake water quality for the production. Because of high water quality requirements for food industry, processed water recycling presents a number of challenges. And we have done in the last year some work on a water safety planning for a food industry. And I think that's something that gives you very good information for the industry on the quality of the intake water and what is the impact if that does not comply with their requirements. Some other opportunities for further research includes improvement of licensing processes, specifically wastewater treatment then as well, improved cooperation between the different governments, making more use of groundwater rather than surface water. And I think the previous speaker on Distel pointed that as well. Improvement of sensing and flow measurement technologies. Yes, I can't overemphasize that, so that you can really get a good handle by management on what happens in terms of your water balance, your water usage, and so on. Then finally, to establish effective partnerships. Thank you very much, Rudy. And yes, thanks a lot.
Thank you very much, Chris. Very insightful presentation, and we'll keep a lookout for this publication on the WRC website. I just wanted to ask about the publication you mentioned on the last slide there, the water quality for food processing. Is that a publication that will be available soon? Chris, I think you're still on mute there.
Yes, I'm sorry about that. Let's go to the previous slide. Okay, it seems like my screen sharing was stopped there. So being the one that I said we were doing some water safety planning for the industry. Okay, that's very specific for the industry, so it will depend on whether they want to make that. But I would aim to see if we can present at least at a conference or similar what we did and some results. I don't know about the availability of the publication because it was for one industry in specific.
All right. Thanks very much, Chris. And we're going to go on to our next speaker now. I'd like to introduce Dr. Pamela Wells. And while I'm introducing Pamela, you'll see a poll popping up on your screen. So I'd invite you to please participate in that. We're going to leave that there for a bit longer this time, so you have a better chance to answer this poll. So Dr. Pamela Wells, thank you for joining us. She's a senior researcher at the Cape Peninsula University of Technology. She holds a PhD in biotechnology and a master's in environmental science and management. Currently, her main research niches are centered around treatment, reuse, resource recovery, and valorization of industrial and agri-industrial residues and effluent. Projects include semi-passive remediation of winery effluent at small local wineries, resource recovery and anaerobic digestion from solid waste from wineries and tanneries, and the use of agri-industrial residues to synthesize biopolymers for plastics manufacturing. So please welcome Pamela Wells. Thank you very much for being here, and over to you.
For the introduction, really. Is everybody seeing my screen all right?
Yes, we can see it and hear you clearly. Thank you.
Okay, perfect. All right. So I was involved in a number of the national surveys as well. I was the edible oil industry, the sugar processing industry, the laundry industry, which the cover of the document isn't here, and then the tanning and leather finishing industry. And I was actually involved with Chris Swartz, our previous speaker, and Ashton Mpofu from GreenCape was heavily involved in this project as well. So if I can't field any questions at the end of it, Ashton certainly will be able to do so, because he's been doing his PhD on leather and tanning and leather finishing. So South Africa produces about 4% of the global volume of bovine hides and ovine skins. And the tanning and leather finishing industry in South Africa contributes significantly to our gross domestic product. We actually net export of hides and skins. We export both exotic skins like ostrich skins, and we process a large number of hides for the automotive industry, which is centered around Port Elizabeth area. So the map on the left shows the distribution of tanneries in South Africa. During the survey, we visited 10 of these tanneries and got very detailed information from them. And we just ensured that we included a good mix of tanneries from different sizes, different types, and from different geographical locations. So I don't really expect you to be able to read everything on the schematic on the left, but it's just to give you an idea and draw your attention to the complexity of tanning and leather finishing, from the raw hides to the finished product. So unfortunately, the tanning process is seen as highly polluting. And this is why most tanneries are now located in developing countries, because the tanneries do struggle to comply with environmental standards in developed countries, for example, in the European Union. Most hides are still tanned using the wet blue process. You can see the picture there. So cow hides are processed by wet blue, and then sheep skins on the right are pickled. So there's a different process for the hides and the skins because the thickness differs quite substantially. But most hides are still tanned using the wet blue process, which is reliant on chromium. So other processes do exist, but there's normally a trade-off on product quality, and obviously product quality is paramount. Trivalent chromium that they use is not itself toxic, but there's always a possibility of it becoming oxidized to the carcinogenic hexavalent form in the environment. And the danger of hexavalent chromium, I'm sure you've all heard of Erin Brockovich, the movie, or seen it when you're a bit younger. And it was based on the contamination of groundwater in a small town in the USA with hexavalent chromium. Tannery effluent also contains a variety of other chemicals used in upstream processes, and those are known as the beam yard or tan yard processes. And the tanning processes, also known as tan yard or tan house, as well as dyeing processes if dyeing takes place at the tannery. So these are really the beam house processes, the inputs on the left and the outputs on the right. So what happens when the hides come in? For ostrich tanneries, the slaughterhouses are often adjacent to the tanneries. So the skins can be processed as they are. They're known as green skins. But because meat is a primary product for cattle and sheep, the hides and skins have to be salted to prevent them from drying out, from degrading. So the skins are just a byproduct, and the salt then needs to be soaked off before processing, which adds a considerable amount of sodium and chloride to the wastewater. And then after soaking, sodium sulfide and lime is used to remove the hair and the flesh from the hides and skins. And next, chemicals are used during deliming and baiting to reduce the pH, remove residual chemicals, and soften the hides and skins. And as you can see in the schematic, the beam house operations result in high concentrations of salts, organics, and sulfides in the wastewater. So it's quite a problematic wastewater to treat. As far as the tan yard processes go, chrome tanning, as I said, is still preferred for hides. So the effluent contains chromium, inorganics, and dyes. Vegetable tanning has been brought in, and it's hoped to replace chrome tanning in the future, but it still needs some development so that the finished product is on a par with the chrome tanned hides. So in contrast to the chrome tanning, sheepskins are pickled, and that is done using salt and sulfuric acid. So no nice chemicals at all are being used. So no matter what the route, though, the effluent from tanning and dyeing contains a range of inorganics and dyes. What's going on here? So in South Africa, this is a typical flow diagram of the wastewater, how it's treated. The tan yard and beam are typically segregated. The fats are skimmed off, and the trivalent chromium is precipitated out. So often, actually, there's no chromium in the final effluent. And sometimes the chromium is actually recycled. And then the sulfides are also oxidized because you don't want to have high sulfide concentrations in your effluent. The lacquers are then generally combined and treated, and normally using the conventional activated sludge process. Unfortunately, it's prone to upsets because there's very high fat content leading to growth of filamentous and organisms, and you don't get very good settling. The wastewater is dried, the sludge is dried, and it's sent to landfill at considerable cost. But depending on the characteristics of the sludge itself, there are opportunities for beneficiation. One tannery I know of is actually looking at experimenting with composting. And we've also co-digested sludge. It was actually part of Ashton's PhD or his master's project, looking at co-digesting to produce biogas. So in most cases, the treated effluent is discharged to sewers, where it's treated in municipal wastewater treatment works. But in some cases, it is discharged directly in marine outfalls. And depending on the local municipality and the route of discharge, the standards vary quite considerably. As you can see here, we've got for City of Tshwane, City of Cape Town, Nelson Mandela Bay, Ekurhuleni, Oudtshoorn, and Mossel Bay. There are some tanneries in Oudtshoorn and Mossel Bay, ostrich tanneries. And it just obviously depends, like for example, in Mossel Bay, the final effluent from the wastewater treatment works goes to quite a highly sensitive area where there's a lot of Bushman paintings, so they don't want high salt content. So it's quite difficult for them to try and comply with that. And then in the NatServe, we also looked at the specific water intake, as Chris was saying that he did with the fruit and vegetables. So in this case, it's how much water they use per hide or skin produced. There's quite a considerable variety, but we compared very favorably with the European standards. It's probably because we're a more water-stressed country and are trying to use as little water as possible, but it was encouraging. And from all of the data that we obtained, we formulated some proposed water use targets, 50 to 150 litres per skin for wet blue process stages, 100 to 200 litres per skin for dye house process stages, and then a total of 200 to 500 litres per skin. And this obviously just depends on the processes that are being used and the types of skin, and that's why you've got such a range. As far as for water resilience, for opportunities for recycling, the wash water from before deliming can be reused as wash water after liming, and which in turn is used in liming. And this is denoted over here by the green arrows. In addition, the pickling and tanning water can be recycled in a closed loop. And this is shown by yellow arrows on the diagram. And it is a very difficult effluent to reuse because of all the chemicals. So, you can't have consistent reuse except for the closed loop with the pickling and the canning. So the water resilience in the industry goes hand in hand with the adoption of new processes to make the wastewater less toxic and obviously more amenable to recycling. And as one would expect, considerable efforts are being dedicated to making the tanning process more environmentally friendly. While many of the more sustainable processes look very good on paper, they still need to be adopted by the industry at large. The most notable example, once again, is the use of vegetable tanning agents instead of chrome. Other examples include replacing some conventional chemicals with enzymes and biodegradable surfactants. Additives have been developed recently to allow low sulfide unhairing and ammonium-free deliming and baiting. Some studies have also been conducted with the use of seawater instead of potable water for some of the beam house operations. But in conclusion, I just want to say that in order to adopt more sustainable technologies, all these new processes and chemicals need to be tried and tested, and it really takes a lot of time, effort, and money. So the EU standards for importing are becoming more stringent, and this does put pressure on leather exporters. But I do think that environmental incentives from the South African government would also assist the industry to become more waste and water resilient. And thank you all for listening. I've only been able to skim the surface of the topic at hand during a very short presentation, but you can download all of the NatServes from the WRC website free of charge if you require any more information.
Thank you very much, Pamela, for that introduction to the NatServe. I was just wondering, of those alternative technologies that you mentioned on your last slide, which one have you seen the most uptake of?
There is very little uptake at the moment, and we obviously can't name any of the tanneries for proprietary reasons, but one of the tanneries in particular is always doing research to try and find alternative technologies. They've uptaken some more low salt processes, but they process green hides as well, which is also very good if they can do that, because that is the salinity in the final effluent is something that's very difficult to get rid of, because you would have to basically do some RO on it, but there's always going to be some residual organics and fats, and your membranes would just be so clogged. So it is a particularly difficult effluent to treat. So anything, I think, reducing the salt content, there are ways of biologically removing the sulfates and sulfides and reducing, we're doing some work on that at the moment, using a biological process for sulfate reduction and partial sulfide oxidation, and you can get conversion to elemental sulfur, which you can then recover. So there is quite a bit of research being done. There's also a lot of research being done in India they've got a lot of tanneries there, and very, very highly polluting, lots of very small tanneries disseminated in quite rural areas as well. So they've got a historical problem with their tanneries. So I think most of the research in tanneries is coming out of India because of the fact that there are very few tanneries in Europe and America now.
Very much, Pamela, and thank you for joining us today for your presentation. We're just going to close our poll now. So thank you for participating in the poll. I see the sort of fourth stage of our resilience, the water resilience journey, is the most popular one, with the alternative supplies, rainwater, treated effluent desalination. But the others are also giving a lot of interest. So thank you for participating in that. And now over to our last presentation for today. We have a video presentation by Dr. Marlies de Versheel. She's a senior researcher in biotechnology and the deputy director of the Applied Microbial and Health Biotechnology Institute at the Cape Peninsula University of Technology. Her research focuses on the isolation of actinobacteria from a range of environments, including but not limited to peatlands, marine sediments, marine sponges, and sea squids, various terrestrial environments, and wastewater. And so we welcome this presentation. If there are any questions for Dr. Versheel, please do post them, and we will send responses to you in our follow-up email with our recording and presentations.
Good morning, everyone. Thank you for the opportunity to share with you the outcomes of the 2016 National Survey of the Water and Wastewater Management Practices in the Textile Industry. My name is Marilise Leroux-Hill, and apologies for not being able to be here in person, so to speak. Should you have any queries related to the study presented here or about the work we do at the Applied Microbial and Health Biotechnology Institute, feel free to contact me at lerousm@cput.ac.za. I'll start off with a brief introduction to the textile industry in South Africa. The previous national survey was performed in 1993. Since then, there's been a dramatic change in the industry. Pre-1990, the industry was quite sheltered and focused on domestic needs only. In 1994, however, South Africa joined the World Trade Organization, resulting in an influx of low-cost imported goods mainly from China and India. The impact on the industry can be seen in the drop in employment levels to approximately a third of what it was in 1990. In order to stabilize the industry, various government initiatives were launched, including the establishment of clothing and textile clusters and the refocusing of manufacturing to the production of technical materials. When looking at the distribution of the textile industry in South Africa, it is clear that the majority are located in the Western Cape, KwaZulu-Natal, and Gauteng province. As can be imagined, various processes take place in the textile industry, ranging from the processing of raw materials to the production of yarn, woven fabrics, non-woven fabrics, and knitted fabrics. These fabrics and yarn are also subjected to treatment processes such as dyeing and finishing, including processes such as waterproofing or the addition of antimicrobial agents and many more different processes. Applications of textiles vary from apparel, household products, bags, medical supplies, geotextiles, protective gear, and many, many more, highlighting the importance of this industry in the South African economy. Various processes take place to get from the raw material to a final product. Earlier processes, such as texturing and spinning, tend to require a more energy than water and vice versa. However, it is not a one-size-fits-all system or approach. Energy and water requirements will vary depending on the products that are being manufactured. Here is an example of the processing of wool for the production of yarn or wool-based fabric. The red arrows indicate processes requiring energy, blue arrows indicate processes requiring water, while the green indicates the addition of raw materials. This schematic clearly indicates that wool processing and refinement is a highly energy and water use intensive process. It is therefore important for the textile industry to be aware of and to function within national and local regulations, policies, and bylaws in terms of water use, wastewater generation, and waste discharge. Ultimately, the goal is to minimize waste generation, reuse as much as possible, resulting in the reduction and prevention of pollution. In order to determine whether the textile industry has shifted its focus towards being an industry that considers resource protection and utilize improved waste management practices, a national survey was performed. The starting point involved the development of a database of all textile manufacturers, the development of a site visit questionnaire covering all pertinent questions related to water use and waste management practices, and an online survey targeted at non-respondents of requests for site visits. The companies who participated in the survey could broadly be grouped according to the main processes that take place. Dyers and finishers, indicated by the abbreviation DF, producers, P, and technical and traditional textiles, or TT. Of the 153 companies identified in South Africa, only 22 responded. 20 indicated that they were not interested in taking part in the survey, while the remainder never responded to any requests. As can be seen from the graph, the 22 participating companies were fairly representative across the provinces and the type of textile processing. In these next few slides, I'll focus on water use, best practices, and an example of a success story. Starting with the water source, the majority of the companies indicated the use of municipal water, while only 2 companies make use of alternative water sources in addition to municipal water. Company DF1 also makes use of river water, but needs to pre-treat it prior to use, while company TT2 makes use of dam water without any form of pre-treatment. Company TT7, a producer of conveyor belts, indicated that they pre-treat the municipal water prior to use. Approximately 50% of the companies indicated that the use of water varies from season to season, while others have a constant water usage throughout the year. It is therefore not surprising that the specific water intake will vary dramatically depending on the type of processes and materials used by the different companies, and as such, individual textile companies should aim to establish their own targets for the improvement of their specific water intake than trying to conform to a national average specific water intake value. In 1993, the average specific water intake was reported to be 137 litres per kilogram of fabric, while in 2016, the average was calculated to be 47.8 litres per kilogram of fabric, a 90 litre per kilogram reduction. This may also be a reflection of the shift of the industry towards more specialized textile production that makes use of more efficient technologies and equipment, resulting in the overall reduction in water use. This then leads us to the various best practices employed by the textile industry in South Africa. The majority indicated the use of water-efficient processes and equipment, constant repairs and monitoring of valves and leaks, as well as continuous optimization of any processes that requires the use of water. Other best practices include the reuse of processed water, recycling of cooling water, reduction of the number of process steps, and then of course the turning off of running taps and hoses. Here is an example of a success story. Company DF1 is an example of how implementing best practices can influence the specific water intake readings. DF1 used to have an SWI of 90 litres per kilogram, but since the company embarked on a water and energy saving program, water use in the production process has decreased to 50 litres per kilogram of fabric. The production process specifically uses about 140 kilolitres of water per day, of which 75 kilolitres is recycled. Water from the bleaching process is pumped into a tank and used in the printing department to clean screens and wash machines. It should be noted that water consumption and subsequently wastewater generation vary according to the volume of production. The target is to use about 30 to 40 litres per kilogram of fabric, but they are still trying to find a way to meet this target, as this will depend on the types of fabrics processed. In addition, water use is monitored daily through reading intake every morning and the comparison of daily readings in order to determine trends, such as changes in consumption per volume of processed fabrics. Taps and other water sources, such as pipes, tapping points, connection to machineries, etc., are monitored daily and repaired where applicable. In many instances, 100% of the water intake result in an equivalent amount of effluent generated. Again, this is highly variable depending on the processes used and whether additional water sources are used. Very few companies have indicated that they monitor the quality of the wastewater generated and that basically that they are dependent on their local municipality to monitor this. They often do not receive any feedback from the municipality, especially if the readings are within the required parameters. Company P2, however, monitored the readings on site, looking at pH, temperature, total dissolved solids, and their average values over a 12-month period falls well within the prescribed municipal limits. Looking at effluent management, 3 of the companies indicated the recycling of effluent for the cleaning of panels. 3 indicated the use of a settling process prior to discharge. 1 makes use of flocculation prior to discharge, while yet another uses filtration and reverse osmosis prior to discharge. Best practices in wastewater management are mostly focused on product and resource recycling, where you look at recovering of residual printing pastes, collection of grease from scouring processes and then siling that off, using rinsing water for cleaning, and recovering potential resources from the wash effluent. The use of new technologies and equipment, so the use of equipment that has automatic controllers, use of enzymes or liposomes, and the combination of processes through new technologies. Chemicals selected for use, looking at the use of biodegradable chemicals and looking at chemicals that have reduced toxicity or even breakdown compounds of these chemicals that have reduced toxicity. And then looking at good management practices such as process optimization, working towards the zero waste concept and the production by color. Best practices reported by the participating companies included the reduction of chemical usage and or substitution for less toxic chemicals. They also look at managing their air emissions in forms of reduction and monitoring, as well as the managing of their solid waste by moving towards reduction, recycling, or taking part in symbiosis programs, as can be seen in the following success story. Company P2 set itself a zero landfill objective. In 2001, 825 cubic meters of waste had to be removed from the company at a cost of 136,800 Rand. By continuously trying to find ways of minimizing and repurposing their waste, solid waste collected in 2014 was down to 25 cubic meters, and was removed at a cost of only 2,952 Rand, a 98% reduction in cost. The company recycles glass, metal, plastics, and cardboard, the proceeds of which goes to a nearby school, and they support initiatives such as Beads for Africa. A part of the company's success can also be attributed to its participation in the Western Cape Industrial Symbiosis Program, or WISP, which encourages various companies from different sectors to connect to determine whether unused or residual resources from one company can be used by another. This initiative has not only resulted in economic and social benefits, but has resulted in decreasing the environmental impact of the participating companies through the drastic decrease in solid waste sent to landfill. Finally, even though energy usage and best practices didn't form part of the 1993 survey, there is a need to understand the potential impact of the textile industry in terms of energy use. The majority indicated the use of electricity in addition to the use of coal, heavy fuel oil, and gas. Best practices are aimed at setting targets for reduced energy use, the use of more energy efficient equipment, reduced use of coal and gas, the use of energy saving lights, and the supplementation of the power requirements for solar power. One company actually indicated that more of a third of the power requirements are met by solar power. Majority of the companies, however, indicated that the use of renewable energy sources is not financially viable at this stage, but they did indicate that over the next 10-year period, they will be looking at potentially investing in renewable energy sources. I wish to acknowledge the Water Research Commission of South Africa for funding the survey, the reference group members who provided insights and guidance, the participating companies from the textile industry, and the Cape Peninsula University of Technology. Thank you very much for listening, and please feel free to contact me should you have any questions.
Thank you very much to the speakers. I think we've come to the end of our workshop for today. So a big thank you to all the speakers that managed to join us today and share information on how to become water resilient in the agri-processing industry. A big thank you as well to all the attendees today that joined us and gained some knowledge, and for sticking through for the rest of the 2 hours, for those that are still here. With that, if you have got any questions, please do not hesitate to contact us at GreenCape. You can use our email, water@greencape.co.za. We will be sharing the presentations together with the recording from this session and any other responses from the speakers for the questions that were not answered live today. So with these words, a big thank you to all of you, particularly to our speakers for gracing us with their time. Till we meet again, cheers, goodbye.